Hello everyone. Today what we're going to study about is matter in our surroundings, basically the effect of temperature and pressure, right? Okay. So let us firstly do the basics, that is the states of matter, right? So we know about solids that they have definite shape. Like let us consider a stone. A stone would have a definite shape. It would have a fixed volume. It has strong intermolecular forces, and you cannot compress a stone. That is its properties. That is the property of solid, right? Next is liquid. So liquids, they have definite volume. They do not have any shape, right? They take the shape of the container. So because particles can slide over one another, right? So if you put it into a glass, so it will take the shape of a glass. If you put it into a bottle, it will take the shape of the bottle, right? Gas, again, gas does not have a definite shape and it does not even have a definite volume, right? The particles are moving freely in the atmosphere and it is highly compressible. Like cylinder is what is there inside the cylinder? There is some gas, right? You know, like the LPG gas, and we can compress it, we can fit it into the cylinder, right? So gases are compressible, right? So these are the properties of the states of matter. Okay, so now this state depends on the arrangement, energy, and the forces of attraction. Like we know solids, they are arranged very closely together. While liquids, they have some spaces between them. The particles of gas have very large spaces between them, right? Okay, so what is the effect of temperature on matter? So this is very important. Okay, so whenever we are heating something, for example, we are heating a, a glass of water, right? Sorry, a beaker which has water on a Bunsen burner. So we are heating it on a Bunsen burner, right? So basically the particles of water, now they gain kinetic energy and they start moving faster. Basically they overcome their attractive forces, even in, solids, or let's say we are talking about liquids, whatever. So any particle you heat, it gains kinetic energy and the particles vibrate more. They overcome the attractive forces, right? So because of this solid, it changes into liquid, that is melting. Ice gets converted to water because why? The particles of ice, they vibrate more. They overcome the attractive forces. Next is liquid. So basically water, it gets converted to, water vapor, right? Yes. So that is boiling. And gas, it is converted into plasma state on extreme heating, right? Okay. Next, let us understand melting point and fusion. So what is melting point? Melting point is the temperature, at which, the paper, the pressure of the solid, and the liquid, right? It converts to liquid and the pressure should be 1 atm, right? The pressure above the solid becomes 1 atm. Like that is the melting point, right? So the pressure, it is the, temperature at which solid is converted to liquid. Basically, simply, it is the temperature. What is melting point? It is the temperature at which solid is converting into liquid at 1 atmospheric pressure. What is 1 atmospheric pressure? Our pressure in the atmosphere, right? So ice, it melts at 273 Kelvin, right? So this is the temperature at which the solid is getting converted to liquid at 1 atm, right? So during melting, the temperature remains constant until the solid melts. Now, this is very important. So, for example, if I have ice blocks, like here I have ice blocks. So, till the time entire ice blocks are getting converted to water, I place a thermometer here. The temperature will remain constant. Suppose the ice is at 0 degrees Celsius, that is 273 Kelvin. Till the time it is getting converted entirely to water, the temperature will not rise. So, till the time it gets converted into water at 0 degrees Celsius, the temperature will not rise, even though you are increasing heat. Let me give you an example. So let us take a beaker of ice, okay, and you start heating it with a Bunsen burner, right? You start heating it. So basically, so you put a thermometer as well. You put a thermometer, and now you increase the temperature, but you see that the thermometer is not changing, right? The reading on the thermometer is not changing. Why? Because till the time the entire ice, which is at 0 degrees Celsius, gets converted to water at 0 degrees Celsius, there will be no change in the temperature. Basically, there will be no change in the thermometer reading. Why? Because all the energy from this heat is being used to break the bonds of ice. That is called the latent heat of fusion. What is the meaning of the word latent? It means hidden. Now, if you want to study more in detail about this, we can get connected through Urban Pro, right? Next is boiling point and, vaporization. Okay. So boiling point is the temperature at which the, liquid, it converts into gas at 1 atmospheric pressure. Basically, we have any liquid which is converting into gas, right? The temperature, and the atmospheric pressure is 1 atmospheric pressure, right? Okay. So water boils at 100 degrees Celsius, right? And this is a bulk phenomena. What is the meaning of bulk phenomena? This means that all the particles are gaining that energy. It is not only the surface particles are getting converted into vapor. No, all the particles are gaining energy and getting converted into vapor, right? Now, what is latent heat of vaporization? Suppose if I'm heating this pan, okay? So at 100 degrees Celsius, it is at 100 degrees Celsius, and I'm also checking the temperature of the steam at 100 degrees Celsius. So till the time entire water is getting converted into steam at 100 degrees Celsius, the temperature will not increase, right? Because what is happening, the energy that we are providing through this, the apparatus that is used to heat this water pan, basically that entire energy is being used to break the bonds of water and convert it into gas. That is the thing. So latent heat of vaporization is equal to heat absorbed without the temperature change, right? Heat is absorbing, but there is no temperature change. Why? Because all the energy is being used to break the bonds of water and convert it into vapor. Okay. Next is evaporation. So again, okay. So evaporation is changing from liquid to vapor state. Okay. Now, that is below boiling point. Now, this depends on a few factors. Surface area. If you increase the surface area, then evaporation is greater. See, if you dry your clothes and they are in crumpled state, they will dry, in very larger time. But if you take your clothes and you spread them properly, right? So what will happen? Your clothes, they will, dry faster. So if the surface area is more, the evaporation is more. If the temperature is more, the evaporation is faster. Let's say, you are taking, you want to evaporate, you have rice and water, and you want to evaporate, basically you are making Maggie and you want to evaporate that excess of water. So you want to increase the temperature for faster evaporation, right? Also, if the wind speed is more, the faster is the evaporation. Now, what is humidity? Humidity is water vapor in the air, right? So if there is already a lot of water vapor in the air, the water vapor from the basically clothes will not come out, right? Yes, because there is already water vapor outside. So humidity increases. If the humidity is more, in those places, the evaporation will be slower, right? Also, evaporation causes a cooling effect because it absorbs heat from the surroundings, right? I hope you got it. Okay, now what is the effect of pressure? So, increasing pressure, it compresses particles like gas into liquid. Basically, we know that, LPG or CNG is stored in cylinders. You must have seen those cylinders, right? In which LPG and CNG is stored. So much amount of gas is stored in a small LPG cylinder. How? Because gases are compressible. And see, if you reduce pressure further, it causes sublimation, right? Okay. So example is, solid carbon dioxide is converted into gas at 1 atmospheric pressure, right? Okay. Now, let us do a quick summary. So, the summary is temperature and pressure determine the state of the matter, and latent heat of fusion, latent heat of vaporization, they're important in phase changes, and evaporation causes cooling. What is sublimation? Direct conversion of solid to gas is called sublimation. Deposition is conversion of gas to solid. Now, if you want to study about sublimation and deposition in detail, we can get in touch through Urban Pro and take one-on-one classes, right? So I hope you understood. And for the last point over here, what is happening, if you want to study this in detail, again, we can connect to Urban Pro. This is just like a brief description of the topic. Okay, so there are a few MCQs which you can read from here and try to, answer it, right? Based on what we have learned today, that ice melts at what temperature, right? What is latent heat of vaporization? What is dry ice, right? Which factor does not increase evaporation, right? So does not increase evaporation, right? So this is what you need to check, okay? Now these are the answers. So you can check your answers, right? Okay. So thank you so much. Thank you so much for paying attention. I hope you really like this topic. And if you want to study more in detail, right, we can again connect through Urban. Thank you.